For this question, we have a circle with a center at -4, 5. So that's the center right there, -4, 5. And there's another point, -8 and -8. So that points around here somewhere, and that lies on the circle. So -8, +8 lies on the circle. The center of the circle is -4, 5. So we can imagine right now that we've got a circle that looks something like this, that has the center we have and passes through that point. So using the equation of the circle, which is x minus h squared plus y minus k squared equals r squared, we know that the first part would look like this: x minus -4, x plus 4 squared, plus y minus 5 squared. But what we don't know is what is the r that's going to go in that space. And my recommendation is for you to use Pythagorean theorem to find it. At Gradeful, we're not big fans of the distance formula. We find it too complicated. But the distance formula comes from the Pythagorean theorem. It's the result of what you would get if you plug two sets of xy points into Pythagorean. For our circle, this bottom side, the horizontal part of that right triangle there, has a length of 4 because it's going from x is -4 to x is -8. So that has a length of 4. The vertical side right here has a length of 3 because it goes from y equals 5 to y equals 8. So we could use Pythagorean, but now that we see that the sides are 3 and 4, this is just a nice classic 3, 4, 5 right triangle. And you should know that there are two main right triangles that you should never have to use Pythagorean for. There's the 3, 4, 5 triangle and the 5, 12, 13 triangle. In real life, there are dozens of Pythagorean triples out there that we know of, but these are the two that you should have memorized for the SAT. So here, because we have 3 and 4, we can sidestep the Pythagorean theorem and just know that the radius is 5. Now, looking at the answer choices, they all had a radius of 5 anyway, so we could have just picked any of them. But in any case, we have x plus 4, y minus 5 equals 5 squared. And that's going to match answer choice D.